But this question I'm taking it from a trial paper that was from 2019. Okay, paper one. So the question says the first four terms of a quadratic sequence are those with 8, 15, 24, and 35. So the first question says write down the next two terms. Okay? Write down the next two terms. Now, for you to be able to do this question, for you to be able to do the question, it would be better if you rewrite the sequence, right? That's your quadratic sequence. Then you calculate the first differences, okay? Calculate the first differences. Those are the first differences. Then your second differences. Well, in this case, you don't need the second differences, but I'm going to just carry on because I'm going to need the second differences for 2.2. Okay, for 2.2, you are going to need the second differences. So the second differences are going to be 2 throughout. Okay, now if I want to calculate the next two terms of the quadratic sequence, what it means is there is a number here such that I'm sure you can agree with me that to get this 35 we add 24 and 11 get 35, right? But there is a 2 here, okay? That 2, okay? Please be aware that if you want to get the next term, you might need to know the second what? Differences. So what number was here that was such that we subtracted 11 from it to get 2 to be what? 13. So that number you add it to 35, then you get what? 48. Are you following what I'm doing? There is a number such that 11 was subtracted from it to get 2. And that number is what? 13. 11 plus 2 gives what? 13. So 13 plus 35 gives you 48. Right? Then we carry on. We put another 2. 13 plus 2 gives what? 15. Then to get the next number, you add these two. 48 plus 15, and you get what? 62. Are you following? So to find the next two terms, you may need the second difference. So this is the fifth term, that's the sixth term. Alright? Are you following that? Then from here now, you can now do 2.2. The good thing is I don't need to repeat the determination of the second difference. I found it. So 2.2, I need to find the nth term. Please be aware that the nth term is also called the general term. And it is of the form Tn equal to an squared plus bn plus c. Furthermore, these first differences, they form an arithmetic sequence. Those first differences form an arithmetic sequence. Are you following? And their general term, based on grade 12, is Tn equal to a plus n minus 1 times d. Okay? Let me write it nicely there. Their general term is Tn equal to a plus n minus 1 times d. That's the general term of those first differences. They form a linear or arithmetic sequence. All right. Now let's move on to 2.2 now. 2.2, we need to determine the nth term, which is of the form Tn equal to an squared plus bn plus c. Now to find that nth term, you need to remember the following. Can you copy the question very well? We need to finish all these questions. So I need to move on. Otherwise, we won't be able to finish. We don't have a lot of time. So 2.2, okay, let me do it there. The questions are there. So I'm now doing 2.2. I'm carrying on from this page. Okay? So first, we need to determine the value of A. So 2A, remember this line? 2A is equal to the second difference. So A is going to be 1. 2A is equal to the second what? Difference. Then the second difference here is a 2. The second difference is a 2. Right? Then, to get B, it will be 3A plus B is equal to the first term of the first differences. And that first term of the first differences is this one. So this value is the one you use to calculate B. You can also use 9, 11, and 30, but don't complicate things. Use the first term of the first differences. Okay? The first term is going to be 3A plus B equal to 7. Okay? So that will be equal to 7. If you decide to use the second term, which is a 9, okay, I'm just showing you this. If you decide to use the 9, then your formula for calculating B will be 5A plus B is equal to 9. Okay? Then you substitute A. So if you substitute A, you get 3 times 1 plus B equals 7. This gives you 3 plus B equals 7. Therefore, B is going to be a 4. Okay? If you decide to use 5A plus 9, so that will be 5 times 1 plus B equal to 9, and then you get 5 plus B equal to 9. So B is going to be a 4. Right? But I prefer that you memorize this, because that will be better for you, because this is the easiest way. Okay? That will be the easiest way. Okay? Then, from here now, we need to find C. So C is given by T1 equal to A plus B plus C. Now, that T1 is the first term of the quadratic sequence. It's not the first term of the first difference. So it will be this one. That's 8. So we'll put 8 here. Where there is A, we'll put 1. Where there is B, we'll put 4. Okay, so you get 8 equal to 5 plus C. So C is going to be 3. Are you following? Then our answer will be Tn is equal to n squared. B is 4. So that will be plus 4n plus 3. That's the general term. Because A is 1. So you need to practice. I think I sent you a booklet with past exam questions. Practice in preparation for the test. Go over a quadratic sequence, right? That booklet has got lots of past papers that I shared with you and the memo. Use that to practice. So that on the day you'll be ready to answer questions on the quadratic sequence. Or is equal to. It's 3 times 1 plus b equal to. That's a new constant. Following. We probably do that in the next time. Well, see, I didn't want to do it today because there are too many days before you write the assignment. So it's better for you to do next week once they're fresh, then a few days later you write. So is there another next week, yeah. How many actually? Well, it's supposed to be Monday. Because I teach other classes. All right. So, next time. Like 4.1, right? You are given the sigma notation. Okay, it's not very clear to you, but let me write it down. It's a sigma from k equal to 1 up to positive infinity, right? Of 5 times 3 to the power of 2 minus k. Okay, so that's the sigma notation. Now, what comes into your mind if you see this and you see that? Based on what you know, what comes into your mind? Huh? Which type of a sum comes into your mind? Sum to infinity. The moment you see the infinity sign, you must think about sum to what? To infinity. Also, here, we have a general term. The k is an exponent. Therefore, we are dealing with what? Sum to infinity of a geometric convergent series. Okay? So the first question says, write down the value of the first two terms of the infinite geometric series. So to find those first two terms, you substitute k equal to 1. So if you put k equal to 1, you get 2 minus 1, which is 1. Right? So you end up getting 5 times 3 to the power of 1, which is 15. So that's your first term. Okay? If you substitute k there, k equal to 1, your exponent becomes 2 minus 1, which is 1. So you end up with 5 times 3 to the power of 1, which is 15. Are you following? Well, the question says write down. You don't have to show the working out. You're just writing the term. Right? Then k equal to 2. You get 2 minus 2, which is 0. 3 to the power of 0 is a 1. Right? 1 times 5 gives you a 5. So the sequence goes like that. Or rather, the series goes along like that. So in actual fact, please, let's not put a semicolon. It's supposed to be a plus, because this is a series. Okay? But here they said write down the value of the first two terms. So we can even write 15 and 5, but I would write it like that as a series. It's a series, so it's better to write it that way. Okay? So those are the first two terms. Okay? Then 4.1.2 says calculate the sum to infinity of the series. Now, to calculate the sum to infinity, we need to know the first term and the common difference. Okay? So, our first term is 15. The common difference, it will be T2 over T1, which will be 5 over 15, and that will be the third. Are you following that? Huh? So the common ratio is T2 over T1, which is got 5 over 30 is the third. Then we use the formula S infinity is equal to A divided by 1 minus R. We use that formula because of this, and also because the common ratio, this common ratio there, is between minus 1 and 1. The common ratio is between minus 1 and 1. And it's also written in the question that it's an infinite geometric series. Therefore, we use the sum to infinity formula, because it specifies here that calculate the sum to infinity. So this type of a question is a very easy question. Okay? So your A is 15 divided by 1 minus a third. This will give you 15 over 2 over 3. Now 15 over 2 over 3 is the same as 45. 45 over 2. You want to simplify that, you can write this as 22 and a half. So that will be your sum to infinity. Okay? Are you following? So this type of a question with sum to infinity comes in many ways. It can come like this, where you're supposed to calculate the sum to infinity. Sometimes you will get a question asking you to find the values of x such that the series is convergent. And you use this inequality. And I explained how you substitute into this inequality and simplify. I explained that. You remember? Yeah. So make sure you know that for an infinite geometric series, the common ratio must be between minus 1 and positive 1. If the common ratio is between minus 1 and positive 1, then you can use this formula to calculate the sum of that series. Any questions so far? So far, we haven't done a very challenging question among these questions. They are very straightforward. Now, 4.2 becomes more complex now, right? 4.2 says, consider the following geometric sequence, sine 30. You should know what sine 30 is. It's a half. Cos 30, square root of 3 over 2. Then there's 3 over 2, dot, dot, up to the last term. So this is a geometric sequence. Now the question says determine the number of terms in the sequence. The last term is given. So all you have to do is determine the general term first. Okay? And finding the general term here is not that difficult. fashion. Then the next question, that is 4.2. 4.2 says consider the following geometric sequence. So you've got sine 30, cos 30, 3 over 2. Now, don't be scared because you saw sine 30, it's a ratio. Okay, sine 30 is a half, cos 30 is square root of 3 over 2. Then we have 3 over 2. The last term is 81 root 3 over 2. Okay? So don't be scared here. Your first term is going to be a half. Now we need the common ratio. So the common ratio, we just say T2 over T1 should be equal to square root of 3 over 2 divided by a half, which is the same as square root of 3 over 2 times 2 over 1. And this gives you square root of 3. So we now have common ratio, first term, and we have got our last term. Okay, so next thing is to write my general term. Then I'm going to equate Tn with, I'm going to substitute Tn with 81 root 3 over 2. It looks scary at a glance, but it's not that difficult. So the next step is to write the general term. So the general term of this sequence is going to be Tn equal to, remember it's a r to the power of n minus 1. So if I write for this sequence, the general term will be Tn equal to, our first term is a half, okay, times the common ratio, which is square root of 3, raised to the power of what? N minus 1. So that will be the general term. This is the need for sign there. Someone might see it differently. This is the need for sign. Just like the pen, sometimes it does that. Okay. So what we are going to do next is just to replace that Tn by the last term to get the number of terms. Yes.
Is that divide?
Yes. It's a divide. Sometimes the pen, so that's divide. Okay. So we're going to equate the last term to the right hand side of the general term. Can I move on? Alright, so we will get 81, or rather, let me write it the other way around. So we're going to get a half times square root of 3, okay? Alright, this is equal to 81 square root of 3 all over 2. Yes, we are replacing Tn, this Tn here, by what? Because this 81 root of 3 over 2 is the last term of the sequence. So if I want to know the number of terms, I just need to know the position of the last term. Remember I told that the position of the last term in a sequence is also the number of terms of the sequence. Okay? So, from here now, because we have a denominator of a half of a 2 here, a denominator of a 2, we neglect the denominator. So we end up having, please don't forget to put n minus 1 there. So we can write this as the square root of 3 to the power of n minus 1 is equal to 81 to the power of, so times square root of 3. Okay. Now the next thing now is to convert the left hand side and the right hand side to the same base. Unfortunately, you can't convert 81 to the base of square root of 3. So this square root of 3 can be written as 3 to the power of a half times or raised to the power of n minus 1. 81 is the same as 3 to the power of 4 times 3 to the power of a half. So it's better to convert to a base of 3. So that you can. Okay, you see in this step here, what type of an equation is this? It's an exponential equation. How do you solve exponential equation? Do the same base. Okay.
But the question said, see what happens if you become 1.
Okay, you see here, it's a half times square root of 3 to the power of n minus 1. I hope you know the answer. Or you can remember this. That if I give you a half times square root of 3, okay, forget about the exponent. This is also the same as a half. Put that in brackets times square root of 3. Okay, it's also the same as square root of 3 or over what? It's the same. Okay? So it means the denominator on the left, I can make it a 2, but already the denominator on the right is a what? 2. So the denominators can disappear. So that I can create this equation, which is exponential. Then from this step now, I need to create a common base. So I convert square root of 3 to 3 to the power of a half, convert 81 to 3 to the power of 4, square root of 3 to 3 to the power of a half. What is the objective? To create an exponential equation with the same what? Base. That's the objective. Are you following? Then you can multiply the exponents here. So it will be 3 to the power of half n minus a half. On the right hand side, this will be 4 plus a half, which is 4 and a half. I hope you are aware. So this will become 3 to the power of 4 and a half. 4 and a half is the same as 9 over 2. Since I have the same base here, I can write this as half n minus a half is equal to 9 over 2. Because 4 and a half is the same as 9 over 2. Now I can solve. So I'll take the minus a half to the right. Okay? So I'll end up having a half n is equal to 9 over 2 plus a half will give me 10 over 2. Okay? Then I can write this as n over 2. It's the same. A half times n is the same as n over 2. Now that the denominator is the same, means the numerators are equal. So I can say n is going to be equal to 10. Okay, wait. It's 9 over 2. Then when I move on to the denominator is the same, so the numerator is not. It's not. Yes? No. 4 and a half is not 9. It's 9 over 2. 9 over 2? Okay, look. Yeah, if you are using a calculator, right? You're using a calculator. So if you're using a calculator, it means if you take the minus and half to the right, you get 5. So, but on the left, you are left with the half n, right? A half n, okay? So you end up having a half times n. Okay, let me write it properly. Can I write it as n over 2? This is equal to 5, because you know there's the 1. What is n? You cross multiply, so you get n equal 5 times 2, which is what? 12. This is what I got here. It's just that you are using a calculator. I'm not using a calculator, that's why I move from here to there, then I see it. But in the end, you should come to the same result. So it means that sequence is got 10 terms. Okay. Right, let's do another question. Okay, this one now I'll delete this. Are you following? So you have got the past papers. Okay, let me choose from the Western Cape, so the Eastern Cape, right? There are lots of past papers for grade 12. There is no grade which has got more resources than grade 12. Yeah, there is no grade which has got more resources than grade 12. Okay, let me do one more question. Let me see which one I can do here quickly, so that we can pick it after that. Right, let me do 2.2 because it involves sigma notation. So this is from the Eastern Cape now. So you write Eastern Cape, then that is September 2019. Okay,